Hello everyone, welcome back to the third part. So, I got so far the instrument up and running to the power supply extent. I had some live sign on the screen. What I'm going to do now is to apply two jumper wires on both vertical plug-in input. Well, actually, to the output of the vertical plug-in, to the input of the vertical amplifier, because I want to see if I can balance both inputs and have some traces in the screen. That should allow me to balance in the middle of the screen, and hopefully we can see some live sign with time scale, perhaps with the trigger. So first of all, let's make this test and measure the voltage to the vertical deflection plates. Okay, this is what I got when I applied the jumper wires, just to let you see exactly to the plug-in socket here in the vertical plug-in bay, and I have a trace. That's really fine. It's not centered, and I was not able to balance. I believe there is one channel that is not working, but look at that. I have a time base working, which is really nice, and I also have triggering working. So things are really promising, I have to say. So as you can see, I have a trace, and it's also nice, very shiny. So very happy so far. Time to troubleshoot the vertical section, and here I have the schematic. So the fan is blowing so much air that is moving like a flag. So this is the output. This is the dual triode output stage, and this is normal stage with the plate output. Then we have the input, which is again with a dual triode, with the first stage as a cathode follower and driving the dual stage again of transistors. Those transistors are not this 2N274 as it should, but it has been replaced with silicon transistors. Those transistors are actually germanium. I have to say that I have made some tests around them. They are not so bad. Actually, it seems that they can work fine in this circuit. I mean, the biasing of the transistor appear to be very close as appear here in the schematic, and the output as well. So I think that actually is not so bad. And of course, the reliability of silicon transistor is much higher, and also in terms of cleanness of signals. So I prefer, but you know, I'm not sure 100% so far that they are suitable for this purpose. So I'm going to measure all the networks around here and see if I can find something wrong. Since it's not easy to have all in camera, what I want to measure right now is the output voltage exactly on the cathode of both channels and both cathode of each channel. So let's see the result. Okay, so first I just will let you see the meter So the first cathode on the channel A, pin number 3, and I have 1.75. Same channel, pin number 8, so is the other arm of the circuit, 1.76. So not too bad. Again, 75. So there is just a few millivolts of difference. No problem. Let's see the other one. Channel B, pin 3, 1.64, and pin number 8, 1.73. Well, this is not balanced and should be balanced. So let me try to balance. Okay, 1.70. Too much. 1.69. $68.2 and 68. Now, okay, a few millivolts. So that's fine. So the first stage is okay. Let's see how is now. Still is very low here. So it means that the amplification path is not balanced. So I will check all the components. I will back up and I will find something of interest. Well, I have removed the jumper wires, and as you can see, the line is almost centered. But I have noted something weird. This is the input of channel A, and as I can see, it's picking noise, right? Just with touching the with the jumper wire, the contact on the socket. But channel B does not have life. So I think that I have some problem in the circuitry of channel B. So let's see if I can find some faulty components there. Well, I made some progress here. Since channel B was not running at all, and channel A it was running, and adjusting the balance control of channel A, I've been able to move the trace on the screen, but not with channel B. So I start to suspect that the channel B is not enabled. And this is the schematic. What I found is that the channel A and B are activated by this multi-vibrator at a rate of 180 kilohertz. So alternate each channel at a rate of 180 kilohertz. And in this small section here, we have a switch that is inside the vertical plug-in that is not connected right now. But in this case, without the plug-in, I should have the point like A and B, A and minus B. So I should have both channels enabled. And actually, if I unbalance the channels, I should see two traces. So I strongly suspect that I have a problem here. And one of these two sides of this that appear to be a flip-flop is not driving the differential amplifier here. So let's try to make some measurements. Well, of course, this after I have checked all the components here and nothing is wrong here. So let's move on this section, which is right this one. Okay, after a few checks, I found a wrong signal here. Actually, I have the minus 45 that is on this grid here on the plate and bring it by through this 180k resistor. So I tested the voltage rails. Here we have the plus 12.6, and I have up to here, but not after the inductor. And indeed, the inductor is open. Since there are no burns traces, I suspect of a mechanical damage. So I will remove it and see if I can save it. And yes, as you can see, here we have the damage. There is a broken wire. With a bit of patience, I've been able to apply a very tiny wire, and now it measures 9.9 ohms. Everything is back in place. The inductor is soldered back in its position. So let's see the behavior. Since I have balanced it before, okay. Oh, look at that. 2 traces. That fixed the problem. Okay, they are almost balanced actually. And time base, it's working perfectly. So, well, of course, we don't know if it's calibrated with centimeters. I left the instrument running for more than 1 hour like that. Everything is fine, stable, nothing has changed. The controls are responding correctly, and it's clearly now the time to address the vertical plugin. And since will not stay in this video, I will skip to the next one, the addressing of it. So that's it for this video. Thanks for watching, and see you soon.